Well. Shopping for a car?
Yep, Carvana made financing a car as smooth as can be.
Oh, yeah?
I got pre-qualified instantly and had real terms personalized just for me.
Doesn't get much smoother than that.
Well, I got to browse thousands of car options on Carvana, all within my budget.
Doesn't get much smoother than that.
It does. I actually wanted a car that seemed out of my range, but I was able to add a cosigner and found my dream car.
It doesn't get much...
Oh, it gets smoother. It's getting delivered tomorrow.
Visit Carvana.com or download the app to get pre-qualified today.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9... Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on the podcast we like to call Space Nuts, although sometimes you might find pieces of plastic and other things in the packet that aren't supposed to be there, but that's not our fault. That's a production issue. We'll leave that up to somebody else to sort out. And joining me, as always, is Fred Watson from the Australian Astronomical Observatory. Hello, Fred.
Hello, Andrew. We have to wade our way through the pieces of plastic,
Yes.
The oral plastic.
Yes, I'm of course referring to something that's been in the Australian news recently about a much anticipated product that was recalled within 2 or 3 days of being released because of plastic.
Quite so.
Which is unfortunate because I wanted some. I wanted some bad. It was a chocolate, by the way. Now, today we're going to be talking about a Chinese space station that won't be a space station for much longer.
No, quite so.
It will be litter. And pieces of plastic, probably. The Curiosity rover has achieved another remarkable milestone, that of its 2,000th sol on the planet Mars. And the Yerkes Observatory will cease operations soon after over 100 years of operation, which is just incredible. Yerkes is also something my grandson says very often. But firstly, Fred, this Chinese space station, the Tiangong-1 space station, is about to plummet spectacularly,
right.
I imagine.
It could be spectacular. That's true, because as it re-enters the Earth's atmosphere, it is sure to burn up. And if it enters in a place where people can see it, and to be honest, that's unlikely because most of the Earth's surface is covered in ocean. But if it does, then it would be a spectacular sight. So the backstory to this, Andrew, is that this spacecraft was launched in 2011. The Chinese have since then launched another manned space station, which not surprisingly is called Tiangong-2. Tiangong is Heavenly Palace, by the way. It's a nice, a really nice epithet for this, what you might call the flagship mission of the CMSA, which is the Chinese Manned Space Agency. So it's their little version of the International Space Station. Tiangong-1 weighs about 8.5 tons. That is nothing compared with the International Space Station itself, which is at something like 420 tons. But so that'll be spectacular when it comes down, but we'll talk about that some other time. The problem at the moment, not soon, that's right. The problem at the moment is that Tiangong-1 seems to have lost contact with the Earth, and we only have that as an assumption, because I believe that the Chinese Space Agency has not confirmed that they have lost contact or control with the spacecraft. But we can see from radar tracking that it is on basically an uncontrolled trajectory. So what happens?
Let me decaying orbit.
Oh, look at that. You've got the words. You and I, masters of decay, which is what happens to nuts if you leave them in the bag long enough. Yes, a decaying orbit. So since its launch, and this happens with all large objects in low Earth orbit, and by low Earth orbit here I mean about 350 kilometers above the Earth's surface. Since its launch, it's had basically, the process is called station keeping. You push up the orbit slightly because it's always decaying slowly due to the residual drag of the atmosphere at that height. Even though that's way above any kind of breathable atmosphere, there is still enough there are still enough molecules of oxygen, nitrogen, and all the rest in the atmosphere to act as a drag on the spacecraft, particularly on the solar panels, which are the bits that stick out the side like large flappy ears. The solar panels tend to slow it down, and that slowdown means that the altitude of the spacecraft gradually falls. And so what operators do is they fire up their booster rockets periodically, and in the case of Tiangong-1, that was roughly every 6 months, 4 to 6 months, something like that, just to lift its orbit slightly. These firings of the rocket motors last a matter of minutes. They're not long affairs, but they push the speed of the spacecraft up, which in turn increases its altitude. And so that's the process that that's happened over the years. And if you look at a plot of the height of Tiangong-1, actually of almost any large spacecraft, it's kind of a sawtooth figure because there's a vertical bit when you're plotting the height against time, where it gets a boost and then it gradually slows down so it reduces in altitude, and then you get another boost. So you get this sawtooth profile. But we know from radar measurements that the last of those what are called altitude adjustments, in other words, a boost to get it to a slightly higher altitude, and actually reached almost 400 kilometers at that time. That last one took place on the 16th of December, 2015. Oops. So it has since then not had any altitude boosts. And of course, what that means is that it just starts falling back to Earth very, very slowly at first, because there's not much drag at 350 or so kilometers. But it's now at a height which is much lower. Its current height is round about 220 kilometers, and that puts it well down into the upper layers of the atmosphere. So the slowdown is increasing, and that is why it's in the news. By the time some of our listeners actually hear this podcast, it might be all over, because the expectation is that Tiangong-1 will hit the ground sometime, basically over the Easter weekend. It will be, probably between the 30th of March and the 3rd of April, and the best guess is the 1st of April, which is quite kind of appropriate, I suppose.
People are going to think it's a joke in that case.
Yeah. As I said, it's very unlikely that anybody will even see it, let alone get knocked on the head by bits of re-entering space debris, because most of the trajectory, which occupies a region between latitude 43 degrees north and latitude 43 degrees south on the Earth's surface, most of that, or much of it, is over ocean. So the odds are that it will come down somewhere in the ocean. But because these things move so quickly, the best sort of prediction that you might get, and this is later in the decay process when radar systems are watching the spacecraft, the best prediction you can get is an error of about 20 minutes in where it will land on the Earth's surface. But at the speed that these things are moving, that 20 minutes translates to almost 10,000 kilometers. Yes. So, that's a fairly big uncertainty region. Yeah. The odds are, as I said, that it will land safely, and we basically will only know about it from the radar measurements. One final thing to say about this is that it is just possible, because the Chinese Space Agency have not really commented on this, it's just possible that they've got just a little bit of fuel left, and that they might be able to use that really in the very final stages of re-entry to give it a bit of a boost that might take it, away from a land surface, if that was the way it was looking. But that's pure conjecture. We simply don't know whether that's the case or not.
And they do tend to keep their cards close to their chest in China when it comes to these kinds of things. I assume it's abandoned. I assume they've not had anyone on there for a while.
That's right. There've only been 2 crewed missions to Tiangong-1, and I think the last one was in about 2015 well, it was 2014, 2015, I think, the last crew that was there. It might be a bit earlier than that, actually. So it's not, it was very much an experimental space station, very much a first step for the Chinese, but a successful one in general. You know, the ending here is perhaps not reflective of the success of the mission as it took place.
Yes, indeed. And it's about the size of a bus, isn't it, this thing?
Yes, it's right. 8.5 tons, as I said. It's the odds are that you know, some of its heavier or more solid components will actually make it to the ground. Most of it will just burn up as this thing hurtles into the atmosphere at nearly 8 kilometers per second. The friction with the air, as you know, because we've seen footage of this kind of thing before, the friction of the air very quickly melts it, and the bits that can burn will burn. The parts that do land tend to be sort of, you know, almost burnt to a crisp, and in that sense, it's a very good thing. We know this from, you know, experiences of previous landings of space debris on the ground. That the fuels and the various volatile compounds are long gone there, so there's no risk of any kind of toxic fuel pollution or anything of that kind by these bits coming down. It's basically just the solid bits of metal that land on the surface.
Well, hopefully in the water, and it sounds like, given the proximity, that's most likely, and people may not see anything, but, you know, you never know. And there's a lot of cameras out there these days, so
there are, that's
somebody
right.
might spot something and we'll get to see this, but yes, we can expect it to happen on or around April the 1st. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson.
3, 2, 1.
Space Nuts.
Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons, and there was just something about their business model that I particularly liked, and a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree, and governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show. Now, Fred, something of a curiosity, and I mean that literally. We're talking about the Curiosity rover, which has just clocked its 2,000th Martian day or sol on the planet, and it's gone way beyond expectations. We've talked about Curiosity a few times, but this rover is just amazing.
Indeed, that's right. It's a great success story. 6 years almost of successful exploration of the red planet. Just to clarify for our podcast listeners, 1 sol, a Martian day, is about 24 hours, 40 minutes. It's slightly longer than our day. And I think, you know, that's one of the rather remarkable coincidences. It's a curious thing that Mars has such a similar rotation period to our own, as well as having the tilt of its axis very similar to ours. It's about 25 degrees. And of course, it's got more or less the same land area that we have on Earth, there being no oceans on Mars, even though it's half the size of the Earth. That's where all the similarities stop. Andrew, but I always think they're quite remarkable things to note.
It's
so
almost
more or
like
less,
somebody designed it as a test case and went, okay, I think we can do this now, and we'll build a bigger one and we'll put it over there.
Yeah, look, all things are possible in this game, I can tell you. Anyway, notwithstanding that, so it's a lengthy period on the surface of Mars, and Curiosity, as you've mentioned, has basically performed more or less flawlessly. There's been a few minor hiccups, but generally speaking, it is in very, very good shape and still doing its mission. And the mission, of course, is to explore a place called Gale Crater on Mars. Gale Crater is a largish crater with, at its center, a mountain something like 5 kilometers high. It's called Mount Sharp. Named after a person rather than the fact that it's pointy on the top. It's not that pointy. From the distance, it just looks like a hill, almost like some of the shield volcanoes that we see, the Mauna Keas of this world and things of that sort. So but it is a significant mountain, and the reason why Gale Crater was chosen for the mission was that Mount Sharp has a lot of exposed strata. So, the whole history of Mars in many ways is laid out in the stratigraphy of this mountain. And so the idea was that, sure enough, that Curiosity would plod its way up Mount Sharp, see how far it got, checking on the history of Mars as it went. In fact, what's happened is that it has found so many different really interesting terrains within the Gale Crater itself that it's not really got very far in its ascent up Mount Sharp. It is at the moment at a place known as Vera Rubin Ridge. It is certainly in the foothills of Mount Sharp, and we have a lovely picture among many others that have come back in celebration, or that have been issued in celebration of the 2000th Sol anniversary of Curiosity. We have a lovely picture of the view back from Vera Rubin Ridge, looking towards the rim of the crater itself, the highest point of the rim. And we can see from that view that the rover has traversed many, many different kinds of landscapes, ranging from sand dunes, they're called the Namib Dunes, because of a kind of a kickback to Namibia, and Namibia, where we have the Namib Desert here on Earth, and the other really interesting things that have come up are riverbeds with pebbles in them.
I mean, gravel. I mean, it's basically gravel that's been formed by flowing water. That astounds me. To find something like that on Mars really just opens up a whole array of possibilities.
Indeed, and mud flats and things of that sort, all the things that speak of a wet past. And of course, that was Curiosity's main mission. Its mission was to identify whether Mars has ever been habitable. And within about the first 2 months, it had put a wholeheartedly or an emphatic tick on that question, that yes, Mars was habitable. We see signs of the right chemicals. There's nitrogen locked up in some of these ancient mud flats and things of that sort that tell us that Mars was once a place that could have harbored life. We still don't know whether it did. We don't know whether it still does. But that is really a feature for the next mission. There are a couple of missions which are designed to explore whether there are still metabolic processes taking place on Mars, and indeed whether there was ever any for example, fossilized microbial life or things like that. Those are for future missions. But Curiosity, as it continues to explore Mars, is certainly showing that it was once a habitable place.
And if they do, in these next missions, find fossil evidence of life that may have existed or even shock horror, life still existing on Mars, it would be extraordinary to have something so close to us that is hosting life. And then, of course, you've got to do the comparison to see if it's exclusive to their planet versus ours, or if there's a relationship, which means life moves around. It will be outstanding if anything ever comes up like that. It will also fuel the probability that life is abundant in the universe.
Yeah.
So,
that's right. You're correct on all those issues, Andrew. But, especially, you're quite right. If we do find living organisms on Mars and can demonstrate that they have a different genetic origin from living organisms on the Earth, then the conclusion is, as you've said, that life is probably abundant throughout the universe, at least at the single-celled organism level. There's bigger questions about vertebrates and higher species in the evolutionary chain, because certainly some voices in the astrobiology world are telling us that the step from a single-celled organism to a multi-celled organism is actually a very big one, and maybe much, much rarer than the microbes themselves forming. But keeping these things in perspective, at the moment we know of life nowhere else other than the Earth, and I think Mars is a fantastic place to look, and we await the results of future missions with great interest. I just hope you and I last long enough that we'll see them and be able to report them on Space Nuts.
I hope so too. Actually, just to finish, one of my favourite photos from Curiosity is one of, it's almost a black and white shot of the horizon. And in the distance, in the dusk of the photo in the distance, is a little dot that we call Earth. I think that's right. Fabulous. Fabulous photo.
It's a lovely twilight picture, as you said. And Earth from Mars, the Earth is a bit like Venus and Mercury are from the Earth. The Earth never strays far from the sun in the sky. So you're always going to see it as a morning star or an evening star, just as we do with Venus and Mercury now.
Except the colour of the sky reverses on Mars, doesn't it?
It's a bit peculiar, that's right.
Very strange. Yeah, they have blue in the morning and red at night, red during the day. And
that's correct. That's right.
I'd love to go there. I really would. Anyway, well done to everybody involved in Curiosity. It's outstanding. 2,000 souls on Mars. This is Space Nuts. Andrew Dunkley and Fred Watson.
0G, and I feel fine.
Space Nuts.
Lastly, Fred, we're going to look at a little bit of astronomy history here in the form of the Yerkes Observatory. Now, this thing's been around for a long time. You probably couldn't blame anybody for not recognising the name. I don't think I've come across it before. But it's over in the United States in Wisconsin. But it's a bit of a sad story because they're shutting it down. It's going to cease operations on the 1st of October.
That's correct. Actually, I think it is slightly less pessimistic than that, in that the university that operates the Yerkes Observatory, University of Chicago, they are very much hoping that the telescope will continue to be used, but perhaps under private sponsorship or tourism sponsorship or something like that, which is why they've made the announcement early that they are planning to withdraw their support for the Yerkes telescope. It is actually a completely iconic piece of astronomy history, and certainly for youthful astronomy buffs like I was once, about 100 years ago, actually not quite that long ago, but the name Yerkes was very high up on the profile. And the reason for that is that the biggest telescope, or the large telescope there, and certainly what was certainly the most important telescope in its early years, that telescope, built in, I think, 1897, if I remember rightly, that's when it was completed. It is the biggest refracting telescope in the world. And by a refracting telescope, we mean one a bit like an ordinary spyglass with a lens at one end and an eyepiece at the other. Although, of course, these days the eyepiece has been replaced by electronic cameras and things of that sort. But the thing is, the lens of the Yerkes refracting telescope it's not the biggest ever made, but it's certainly the biggest still in operation. It is 40 inches, or basically 1 meter in diameter, and that represents round about the largest size, almost the largest size that you can make a lens telescope because glass is not perfectly rigid. And because you're supporting this big lens only around its edge, unlike a mirror, which you can support from the back, you're supporting the lens around its edge, so it tends to sag. So if you make one much bigger than a meter or so,
it's actually useless.
You run into problems. That's right. You run into distortion problems. There were a couple of bigger ones that were made, but never properly entered service. One was used for an exhibition in Paris at the turn of the 20th century, and the other never left the manufacturers' workshops. But they were slightly bigger than the 40-inch. The 40-inch certainly the biggest operational refracting telescope, and because of that, it did extraordinary work during the first 30 or 40 years of the 20th century, most especially in measuring the distances to stars, because that's something that you need this kind of telescope for. We do it by a means called parallax, which means that you look at the star, you measure its position very accurately on 2 occasions separated by 6 months. And in that time, the Earth has gone halfway around the sun. And so its vantage point has changed slightly. And you can pick up that vantage point as what we call parallax, or that vantage point change as what we call parallax, and measure the distance by triangulation. It's the time-honored way of measuring the distances to stars. And the Yerkes telescope was very good at it. But of course, really only, not very long after the Yerkes telescope was built, the die was cast against large refracting telescopes, because it was at that time that the big reflecting or mirror telescopes started to come into play. And the major milestone with that was in 1918, when the 100-inch or 2.4 meter, 2.5 meter telescope at Mount Wilson was built. And that is the telescope with which we discovered that the universe is full of galaxies, that it's expanding, and all the rest of it. So that was very much the future. And of course, all major telescopes today are reflecting or mirror telescopes. There aren't really any big refracting telescopes being built. That's the backstory. The front story is that really for, I think, at least 20 years, the Yerkes refractor has been used mostly for education, for university and school groups, for outreach to get the public involved with science, things of that sort. But those operations have been sponsored by the University of Chicago, which owns the telescope. What they now want to do is cease their funding of its operations, and I understand that that's all about the limited amounts of funding that science has available. We're going through something very similar to that here in Australia at the moment. So the idea is that if you advertise the fact that you're pulling the funding early enough, then it may well be that you can get, perhaps big business, perhaps the private sector in terms of education to really to take on the telescope as a going concern. And one of the spokespeople for the University of Chicago on this issue has said that it would be a lost opportunity not to find some agency that would take it over as an educational facility. But they say they understand it's an expensive facility to maintain and run, and that's why they've made the announcement early in order to try and gain interest or garner interest in the wider community. They say in their statement, we hope that it will continue as a valuable resource to the community and visitors to the Lake Geneva area. And I can only endorse that. It would be terrible if the Yerkes telescope was dismantled or stored away in boxes or just allowed to rot. It really is a very important piece of astronomical infrastructure, and it will be great to see it continuing in some capacity.
Oh, yes, and I do hope so. And it is a classic observatory. I mean, it is just, you look at it and you go, yeah, I know what that is. It's got the dome, it's got the slit door, and it's built on a beautiful 1890s facade, a beautiful brick building. It is a remarkable piece of architecture, really, when you look at it. Amazing.
Yeah, and amazing technology inside too. It would be staggering to see the Yerkes telescope up close. I haven't seen it. I have seen the slightly smaller version that's at Lick Observatory on Mount Hamilton, the 36-inch, but the 40-inch would be really quite a monster to stand underneath.
Oh yeah, I reckon. And would it have suffered in more recent times from light pollution issues?
Yes, all these observatory sites suffer from the ones that were being built in the 19th century. They suffer from light pollution because they were all built near cities. They were built near where the astronomers are. It's only really since the advent of wide-bodied jets in the 1960s that we've been able to build telescopes where the conditions are perfect, effectively, and ferry the astronomers backwards and forwards to use them.
Yeah. All right. Well, let's hope someone philanthropic comes forward, or an organisation comes forward and says, "Yeah, we'll have that. We'll look after that."
Yeah, I hope
can't
so.
let that one slip through the cracks.
Exactly.
But, what a remarkable piece of architecture it is. Certainly worth restoring, even if it can't continue as an observatory. That wraps us up, Fred. Thank you so much. Now, we've got a bit of a backlog of questions, which I hope we'll be able to get to soon. We certainly do appreciate your feedback, so we'll have a look at those and see if we can get some answers sorted. The truth is we've read them and gone, oh, that's too hard.
Speak for yourself.
I will. And thank you as always, Fred.
It's a great pleasure, Andrew. Good to talk, and we'll speak next week. And we'll look at some questions too.
Indeed. Fred Watson from the Australian Astronomical Observatory. And from me, keep the cards and letters and e-notes coming in. We do enjoy getting your feedback, and we will catch you again next time on Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.